Welcome 7th International Symposium on Multidisciplinary Studies and Innovative Technologies. The symposium is organized by Tokat Gazi Osman Pasha University from Turkey, and also the symposium is technically sponsored by IEEE Turkey section. Thank you for your scientific contribution and support symposium. Let's start session. First session. If you want, if you are ready, first paper belong to dear Sanjana Devangan.
Sanjana Devangan, electronic equipment waste generated by computers and its effect on public health in India.
Okay.
Dr. Sanjana, Prashant, Bhagyashree, anyone may present, please. Thank you.
Okay. You have 10 minutes, please. Dear Sanjana.
Sanjana, you are not audible.
Good morning. I'm going to present.
Yeah. Okay. You have 10 minutes, please.
Good morning to all. I'm going to present a paper on electronic equipment waste generated by computers and its effect on public health in India. My presentation includes the following points. It includes introduction, literature review, problem identification, research objective, research methodology, expected outcome, and conclusion. So I will start with introduction. Includes a wide range of electronics such as home appliances, computer, mobile phones, and all which are run by electric. In terms of toxicity, e-waste added to chromium, lead, and mercury, chlorofluorocarbon, polycyclic aromatic hydrocarbon, polybrominated diphenyl ethers, polychlorinated biphenyls, and polychlorinated dibenzoparadoxine, furan, etc. In 1994, approximately 20 million computers were expired and turned into e-waste, while in 2004 it crossed 100 million. Due to the global demand for the latest model of computers, the stability in the market is declining, finally resulting in e-waste. As per the study done by Orleans and Guan, the workers who are involved in the disposal of e-waste are suffered more health issue due to lack of knowledge of disposal and also due to the lack of proper equipment. In the year 2008, Flew et al. Show in his studies that the major pathway of toxic heavy metal in the year 2013, Chen et al. Show through his studies that rice is the main staple countries, and among these China, which is one of the leading e-waste recycler, its dietary percentage of presence of polybrominated diphenyl in approx is high. Food had surpassed the US EPA reference, which is 100 nanogram per day per kilogram to 931 nanogram per day per kilogram. Zing et al. Explained through his studies that fresh water, fish, seafoods, etc. are the main source of contamination of PBD in human. Year 2014 also explained through their studies, breastfeeding mothers of dumping and recycling area has a higher concentration of PBD in their milk, which is 572 per nanogram per day per kilogram, which is 57 times more than that of control areas. In 2011, Zhang et al. Shows toxic heavy metals like cadmium, lead, nickel, PBD, etc. concentration found in the human placenta after childbirth is very high to the reference standard. Placenta collected from the Guang, China, which is a well-known e-waste collection center, shows increased concentration of 301.14 nanogram per gram of lead PBD concentration 19 times higher than the control site, which is 19.5 and 1.02 nanogram per gram respectively. Hu et al. Show that the data of blood lead level of 165 children in the e-waste recycling area of Doing, China had more concentration of blood lead level ranging from 4.40 to 32.67 microgram per liter. Then those living in the Canadian whose blood lead level ranges from 4.9 to 3.1 microgram per liter, showing the correlation between the blood lead levels in the children and the number of e-waste workshop. The problem identification from the literature review are PCB is a carcinogenic and it also affects the immune system, reproductive system. PBD cause long-term injuries to human health and poisonous when burned. Plastic form of PVC material fluorine affects the respiratory system. Cadmium in the battery are acute poisonous and injurious on long term. Chromium present in floppy disk cause allergic reaction. Lead present in the printing wiring board, CRT screen batteries damage the nervous system, circulatory system, kidneys, and learning problems in kids. Mercury present in fluorescent in backlight is acutely poisonous and health in long term. Electronic equipment waste generated by computers and its effect on public health in India is to study the effect of toxic PBD generated by computers e-waste on human health in various parameters like infant, children, and adult body. To study the effect of toxicity of heavy metals produced by computers e-waste on human health. And the third one is to study the effect of PCBs, which is also produced by computers e-waste on human health. This is my research methodology. The expected result would be with the help of the proposed work, it will be possible to determine that running water bodies also carries e-waste contaminant which can pollute water system as well as agricultural soil also and thus to crop. After detecting the presence of thresh metals contaminants, their concentration will be determined, which will be compared to the recommended level, and on the basis of this, it will be determined as harmful for human or not. Production and application of activated carbon will be done if the water system and the agriculture field soil found to be contaminated. Absorption efficiency of produced activated carbon will be calculated. The absorption efficiency of activated carbon produced from various sources will be compared. Finally, I will conclude with this. It is expected that the soil and water sample could be helpful for minimizing the contamination of water source, as well as it can be used to eliminate metal contamination from the other source also. This is my reference.
Okay, thank you for your presentation.
Thank you.
Dear participant, do you have any question about the study?
No questions, sir. Thank you.
Okay. Thank you again. I wish you success, dear Sanjana Devangan. Next paper belong to dear Poonam Shrivastava. Dear Poonam Shrivastava, are you ready to present?
Sanjana Devangan, please. Yeah, thank you. Miss Poonam or Nita Tripathi.
Okay. If you are ready, you can start your presentation.
Yeah. Poonam.
You have
Yeah,
you
thank
have
you. Please go
you
ahead.
have 10 minutes, please.
Poonam, you may please start. Thank you.
Okay, you can start if you are ready.
Good morning, sir.
Good morning. You can
Please start.
start
Please
your
start.
presentation.
Sir, myself Poonam Srivastava, PhD scholar from the Shankaracharya College, Bhilai, India. Today I am going to present a paper, SLR paper on the autonomic computing based respiration disorder assessment using the speech parameters. The outline of the presentation is the introduction, why SLR, objective, related work done in this area, problem statement, contribution of the work, Prisma introduction, methodology, results, followed by the conclusion and future aspects, and finally the references. Introduction. As we know that the healthcare is of the utmost importance in the human society as the quality of the life depends upon it. As per the gold norms, the respiratory disorders, which are the common health problems, as they represent the health burden to the people around the world and affect around 400 million people worldwide. Nowadays, the speech analysis is a very important area in research in the biomedical field. Therefore, in the pre-diagnosis of the respiratory disorders, the speech analysis may play a very vital role and act as an effective tool. Now we are having the systematic literature review on this topic. Now, what is a SLR? SLR is basically a type of sub-study that summarizes and compiles what has been published in the literature on a particular subject or a topic. It is used basically because it is easy to map the existing understanding on any problem. It is rigorous scientific methodology. It is quick and it is easy to publish and highly cited. Objective of the paper is to define the autonomic computing in the terms of self-care and the self-management to assess the disease using the machine learning paradigm. This is a related work done in this area, which defines that how the speech parameters can be used for the assessment of the respiratory disorder using the autonomic computing. Problem identification. Regarding to the research gap, we have observed the basic problem in this area is that the main work has been done with the help of the lung images and the lung sound analysis. But we have proposed here the speech analysis and the speech parameter variation for the assessment of the respiratory disorder. In addition, we have also observed that the small database is one of the limitations which can be overcome by collecting the huge data. As for the machine learning as well as for the deep learning analysis, the large number of data is basically required for having the significant result. Contribution of the work. The work is basically compromises the respiratory disorder based characterized research. Present the self-management method applied to the respiratory disorders. It states the necessity and the significance of the speech parameters for the assessment of the respiratory disorder, and finally, exploring the research gap over the past decade. Prisma. Prisma basically defined as it is a work in which we are going to have the inclusion and exclusion criteria, in which the inclusion criteria were the keywords we are providing. Exclusion criteria are the few criteria which is going to exclude the unwanted or unrequired data. And finally, we will have the identification of the required work to be done. Methodology. The methodology compromises of the using the Prisma methodology, we are going to perform the SLR, that is a systematic literature review, which involves the identifying, selecting, criticizing, and evaluating the research to answer a formulated question. Here we have implemented all these in the Google Scholar, PubMed, and the cross-reference. The keywords which we have used were the respiratory disorders, speech parameters, autonomic computing, self-management, machine learning. These were the mainly compiled for the selection list. In total, the 1,000 records were considered with the various databases on the Science Direct, IEEE Explorer, Elsewhere, PubMed, Web of Science, IOP, and MDPI. This is the Prisma framework which we have been designed, in which we can see that initially we were having the 1000 records which were screened, and finally we got the 722 records, which further excluded the unwanted records and reaches to the figure of 66, which on further evaluating we get a number of 51 records to be eligible studied. But finally, upon more screening, we get at a final, we get the n is equal to 15 records which were meeting our criteria. Eligibility criteria. As I have already told, the inclusion criteria basically comprises of the keywords which were the respiratory disorders, speech parameters, autonomic computing, machine learning, and the self-management. And the exclusion criteria comprises of the non-respiratory disorders, then the speech analysis for the other than respiratory disorder analysis, then it is going to have the review papers, book chapters, then it is going to have over there the unpublished papers or irrelevant articles and the surveys. So this all exclude the articles, and finally we got a figure of 15 articles which were completely meeting our criteria. Data extraction, as I have already told, whatever the data has been extracted, it is going to be saved in the Excel spreadsheet or CSV or RIS files to be sorted efficiently. This we have going to be after filtered out or sorted to remove the book chapters, duplicate data, and the review articles. Then we got the data items. Data items comprises the two things. First, it is going to have the correlation, clustering, and collaboration of authors and co-authors, which indicates that many of the authors are going to be act as a co-authors in the other papers. So we are going to have the clustering of it, which is shown by the figure, in which we can see that many of the authors are there which are acting as a co-author in the other papers. So basically they are going to have the clustering and correlation between the authors and the co-authors. In the similar manner, we are going to have the word item based study, in which out of 150 words elements were identified by this approach and 9 clusters were formed. These words are basically, as we have considered as the keywords, that is a self-management, COPD that comes under the respiratory disorder, and the speech therapy that comes under the speech analysis. This is the clustering which we have got a correlation between the articles that occurs on the basis of the items which we have defined. Then the result. The result shows that over a decade, how much papers has been published or the percentage of the paper published in the last decade. By this graph, we can easily observe that the total number of paper published in 2012 were the maximum, and it gradually get shorted regarding the 2018. Then in 2019, the more number of papers has been published in this particular area. Then after that, a saturation has been observed in the 2020 and 2021 till 2022, that the number of papers will be almost the same. So in particular area, this number of papers has been published. Conclusion, by this we can observe that total 722 articles were considered, out of which we finally got the 15 papers which were meeting our criteria. And throughout the review or SLR, we have observed that the machine learning and deep learning played a very vital role, while significant role while dealing with the assessment of the respiratory disorders with the help of the speech parameter analysis. However, the most common limitation was the small data set, and also that the very few work has been done in the speech parameter analysis apart from the lung sound or the lung images analysis. These are the references of my paper. Thank you.
Thank you for your presentation. Dear
Thank you,
participants, do you have any question about the paper? Okay, no questions. Thank you again. I wish you
questions.
success in your career.
Thank you, sir.
Next paper belong to dear Ravi Kumar Sachdevan. Are you ready to present?
Yeah, empowering hepatitis diagnosis.
Okay. if you are ready, you
Ravi
can
sir, are you
start your
there?
presentation.
Yes, sir, I'm there, sir. Good morning, sir.
Can you, yeah, good morning. Can you please share your presentation?
Yes, sir, sure, sir.
Yeah, thank you. Please go ahead.
Please, you have 10 minutes.
Good morning, sir. Good morning, everyone present here. I am Dr. Ravi Sachdeva. I'm working as professor at Chitkara University Institute of Engineering and Technology, Chitkara University, India. And today I'm going to present my paper on empowering hepatitis diagnosis using RFE feature selection. So these are the content of my presentation. First of all, I will introduce about the hepatitis disease. I will put a
Ravi sir, sorry for interruption. Can
Yes,
you
sir.
please make the screen full screen mode?
Sure, sir. Sure, sir. Just a minute, sir. Is it visible, sir, now?
Yeah, thank you. Yeah, fine. Go ahead.
Yes. Okay. So first of all, I will introduce about the disease, what hepatitis is, and why it is important to diagnose hepatitis using machine learning. And after that, I will discuss about the feature selection, and I will tell about the method which I've used for the feature selection. Next, I will discuss about the dataset used for the diagnosis, and then I will discuss my methodology. And afterwards, the classified performance will be described. And at the end, conclusion and future score will be described. So first of all, what hepatitis is? Basically, hepatitis is under the list of extremely threatening diseases in the world. And it is one of the major reason for the deaths due to disease across the world. Over 1 million people all over the globe are affected by this disease each year, and this statistic itself tells that how important itself becomes to apply some of the techniques so that we can detect the hepatitis at an early stage so that the death rate can be reduced. Basically, what hepatitis is, it is a kind of liver inflammation, and it is generally reported among the people due to viral infections. And what basically hepatitis do? Hepatitis causes hepatocyte, which is basically destructing the cells of the liver, and that is why the timely diagnosis becomes very important so that the survival rate can be increased. And of course, we can use the machine learning techniques for hepatitis diagnosis. So first, discussing the methodology, I will discuss the feature selection. What feature selection is? Feature selection is the process of selecting a subset of features out of the available features, which actually contributing towards the model of disease diagnosis. In feature selection, what happens that basically we identify only those features which are actually contributing towards the model prediction, and we remove all other features which are not contributing towards the model. And the technique which we have used in our this paper is RFE, that is recursive feature elimination, which eliminate the features recursively on each and on the consequent stages. So the dataset which we have used is hepatitis dataset, and it is basically available on the UCI repository, and it's a public repository where the people can access the dataset. And dataset has 19 prediction attributes, and there is one class attribute which has the 2 possible values, which tells me whether the people is going to have the hepatitis or not. And based on the 19 prediction attributes, we are going to apply the feature selection, and then we will produce our model. The total number of records in our data set is 155. This is the overall methodology which we have used in our paper. We have taken the hepatitis dataset. As I've told you that we have taken this hepatitis dataset from the UCI repository. We have applied the feature selection technique, RFE, and this RFE has given us the set of features which we can use for model prediction. And then we have applied 4 classifiers: SVM, KNN, AdaBoost, and DT. And then the classification has been done. Basically, what we have observed that the accuracy which is achieved without feature selection was less than the accuracy which is achieved using feature selection. By applying feature selection, we have got better performance in terms of each and every parameter, not only accuracy, basically the other parameters also behaved very well, like our sensitivity, specificity, F measure. So all of these features got better by applying the feature selection. And to apply the classification, basically what we have done, we, as I told you, that we have the 155 records in our data set. So some of the data was used to train the model and some of the data was used to test the model. So using that test data, what accuracy we have found, that I'm going to show you in the next slide. So basically, this is the classifier performance without using feature selection. You see that like the 4 parameters we have used for the performance evaluation, that is accuracy, sensitivity, specificity, and F measure. Accuracy is that it is the ratio, it is the percentage of the cases which were accurately identified, whether they can be with yes result or with no result. But what if in our test data it says yes? So actually our model has identified it yes, and if our test data says it is no as the result, our model has also said it has no for the hepatitis. So this ratio is basically defined as the accuracy. And what sensitivity is? Sensitivity is basically, it is the ratio of correctly identified positive instances, that is the sensitivity. And specificity is the ratio of correctly identified the negative instances. And F measure is basically the harmonic mean of sensitivity and specificity. And if you observe that this accuracy with SVM, we obtain 85.87, KNN 85.93, AdaBoost 90.27, DT 86.53, and similarly the other these performance parameter values are also shown, like for sensitivity, specificity. And if we compare this one with the classifier performance after using RFE feature selection, we observe that the accuracy has increased for all the classifiers, and SVM has given us the best results. So SVM has got 94.78, Canon got 88.73, AdaBoost 91.04, and DT is 88.95. If I show it using this the bar graph, so this is the bar graph comparison of accuracy without RFE, and this is the bar graph of accuracy with RFE. If you observe both of these graphs, so you will observe that the accuracy has increased for each and every classifier after applying the RFE technique. So what basically we have done in our paper, we have produced a model for classifying the hepatitis, and this proposed system has selected the features using the RFE method. And 4 classifiers we've used: SVM, Canon, AdaBoost, and DT to perform the classification. And what we have observed in our experiments, that feature selection has contributed to increasing the performance of all the classifiers. SVM achieved 94.78% accuracy, Canon achieved 88.73% accuracy, AdaBoost achieved 91.04% accuracy, DT achieved 88.95% accuracy after using RFE feature selection, and SVM in combination with the RFE method achieved the highest accuracy. That is why we can say that the doctors can use the proposed system to diagnose the hepatitis at an early stage, and of course this is going to reduce the death rate and increase the survival rate of the patients. What our future scope is in future, what we can do, what's planning to do, that we will apply the techniques to balance the classes also, and we will perform the experiments, and we will observe that whether what kind of change is there if we apply the class balancing along with the feature selection. Besides that, we will try to test our model in the real-time data, in the real-time scenario, by assigning it to the various health practitioners, so that the real-time feedback can be achieved, that whether the attributes which we have identified to be contributing to the diagnosis of hepatitis are actually working in the real time or not. So these are the references which we have used for working on the paper. Thank you. Thank you, sir.
Thanks for your presentation. Dear participants, do you have any question about this study?
No questions, sir.
Thank you, sir.
Very good presentation
Okay.
indeed.
Okay, no questions. Thank you again. I wish you success. Next paper
Is Monica Arya, I think.
Monica Arya, yes.
She is having 2 papers, ML based and adaptive streaming.
Okay.
Monica, are you there? Monica Arya?
Yes, Monica Arya. First paper, ML-based feature selection technique for imbalanced data streams. Are you ready to present?
Monica Arya, can you please share your screen?
Monica Arya is online or
I
So
think
actually, so I'm
sorry?
Ayushi. Actually, first paper is I will present the machine learning data.
Okay,
Okay.
okay, you
Please go
can
ahead.
start.
Yes, sir.
Please share your screen.
Yes, sir.
Okay. Go ahead.
You
Thank you.
have 10 minutes, please.
Yes, sir. Thank you, sir. So good morning, everyone. I myself Ayushi Pillai, and I'm presenting my topic on ML-based feature selection technique for imbalanced data stream. I'm doing MTech. I'm a MTech student from BIT Durg, India. So here, the table of contents includes the introduction, related work, problem formulation and proposed work, result and discussion, conclusion, and finally the references. So I here start with the introduction part, where as we all know in today's world, as technology is growing and getting popular, a vast amount of data is being generated. So it is very challenging to get the each data's information accurately and will take more time to execute. So to find meaningful information from the data, we the feature selection is used, and the feature selection main aim is to find the features from the given set of features and improve the performance of machine learning algorithm. So the primary goal of this study is to show the efficacy of machine learning using the proposed feature selection in an imbalanced data. Next, here come with the feature selection. So the basic objective of feature selection technique is to identify the feature subset that improve the classification and the quality of the data with requiring less computational effort and keeping the entire initial feature set. With feature selection giving the two parts, the filter methods and the wrapper method, and it again defined with the information gain chi-square. Fisher score correlation coefficient, meaning absolute deviation with wrapper methods, forward feature selection, backward, executive, and RFE, that's recursive feature elimination. Then I start with the filter method. In filter method, the framework can employ which feature selector using the complete feature set, and it give to the feature selector for selecting and search, and the information content is evaluated the function, and it gives the optimal feature set and the classification of model. Basically, filter method is a way of selecting the subset of most relevant features from the original feature set by removing the redundant and relevant methods and avoiding the noisy features. Next, come with the wrapper method. In wrapper method technique, the foundation of feature selection process is a particle of machine learning algorithm. In initial state of set of all features, it's given to the considered of features, and then machine learning algorithm is applied with the performance, and it's repeat until we get the optimal feature set. In our method, the contribution and novelty comes to propose a new hybrid feature selection that integrates the filter and wrapper approach, then it's the improve of machine learning performance, and that select the optimal number of features in an imbalanced healthcare data set. The novelty of this approach is that to generate a predictive feature set, which is further optimized by the wrapper and ensemble method. And the model is further improved with the ensemble and stratified cross-validation to achieve promising result and performances. Next, the proposed approach is tested and validated on various imbalanced healthcare datasets. And in addition, the study contributed several significant results to comparative analysis. Now, here comes the related work, where the literature survey gives the authors who are given the methodologies on various subjects. Here, Webull Canada introduced an approach of on LR and SVM, as Khalid used RSR method for further tuning of optimal feature selection. Jae Yong used filters and wrapper method. M. Arya et al. Used evaluated original feature set by filter wrapper method. M. Labani used multi-iterative discrimination, creation, and for text classification. It used pre-processing techniques in clinical datasets. A. Motwani et al. Uses an ensemble deep learning to extract the data. L. Naka used this study focuses basically on filter wrap and embedded learning methods. G. Bajaj et al. Used rank-based feature selection wrapper approaches. P. Chaurasia et al. Used a proposed new framework for BP estimation, used single channel PPG signals. Here, how the article based on feature selection and machine learning given according to references, they have used some have used LR, SVM, FS, A. Motwani use SVM ensemble FS. How it is compared to our study? In our study, we have compared with all LR, RF, DT, SVM ensemble feature selection. Now come with the problem formulation and proposed work for research and question answered. So how does it helps us to get the this idea of proposed work? So how does the machine learning help to perform in imbalanced data? Next is how does the feature selection technique enhance the machine learning model performance and lessen the type 1 and type 2 errors? Next is the proposed method is prominent with the optimal features of subsets. Next, which the characteristic are key predictors for performing the better prognosis. So now our proposed novel hybrid feature selection and optimization, there are two significant steps. First, the two filter-based technique are applied in first step to determine the subset of locally predictive features. In the second step, the wrapper method within simple is applied to optimize the feature set to generalize the filter wrapper methods and improve the classification of efficiency. Here, the flow diagram of it states that the feature subset are rapidly selected using statistical feature selection method and modified correlation based on subset selection with greedy stepwise search and chi-square method has been implemented as filter-based methods. Then the selected subset is fine-tuned using the wrapper approach, recursive feature elimination and ensemble classifiers, and the framework is built and tested on imbalanced data sets for the healthcare domain. And finally, we get the optimal feature set. Now here, in the EHR, that's healthcare record, it's we get the data from there and pre-processing is evaluated and the missing imputation values is getting. Now we analyze the data and it sends to filter approaches. The top K feature subset in the interaction with the RFE, we get the novel hybrid feature selection approach, and finally we get the optimal feature set and model performances. Now this is the algorithm, how we use filter methods. In this, we have generated top K feature per test, and we in F1, that's a feature set, then generated the top K features for F2, and we do the intersection of that, and then F0 is that's an empty set is applied to optimal feature set and the ranking of empty list. Then the set of classifiers that C1, C2 up to Cn, and we supply the RFE of ensemble to its C, Si. Then we repeat until we evaluate the cost of subsets. Then we have trained the classifiers with update the optimal features, then evaluate the performance with cross validation such as the cost is high, and calculate the ranking of predictors, and we end the repeat and return the F0, that's the rank and performances. Now the result and discussion, the evaluation of results shows the proposed hybrid approach outperformance start state of methods and methods of performing determining optimal features, the performance of classifier on the imbalanced data set. It can be concluded that decision tree and random forest perform best with the proposed hybrid approach for optimization. Here comes the compound correlation map of diabetic heart and liver disease patients, how the correlation ranking ranges from -1 to +1, and how we goes to positive +1 ranges. It clarifies the correlation between the two variables are with great efficiency. Now it gives the prediction performances. We compared with accuracy, F-score, precision, sensitivity, specificity, ROC, and the feature set. Here we get the LR, SVM, DT, RF, and our proposed method. We get in our proposed method, we get the efficiency with the highest numbers. Now with the ROC curves for diabetic heart and liver disease, with the x-axis true positive rate and in y-axis false positive rate. It more inclined towards the true positive rate. That means our research have good efficiency. Now with k-fold cross validation, k-fold cross validation. In k-fold cross validation is a technique for evaluating the predictive models, and the data set is divided into k subsets. So in this also we get the efficiency. Now the final conclusion, this proposed work presents an effective model based on the concluded diagnosis and imbalanced data set, the hybrid approach has proven to reduce the original feature set size with better performances. And the approach can be further implemented and tested with other machine deep learning models and different data sets. Now the references. Thank you so much.
Thank you for your presentation. Dear participants, do you have any question about the study?
Yes.
Okay.
Ayushi, can you please justify what do you mean by cross-validation?
Yes, sir. Yes, sir. Basically, cross-validation is a technique that evaluates the predictive models, and it's split into 3 different categories of training, validation, and testing. So we test the data, and we basically we split that into training and testing of data, in which if we have number of data sets and we stratify it to the data of size, so we split it and we send particular amount of data for testing, and and side by side we do training also, and we test the data that how it work on that, and then we validate it.
Okay, Ayushi. Nice presentation.
Thank you,
Sir, I think we can move for the next presentation. Monica Arya. An adaptive streaming feature selection technique for classifying non-stationary data streams.
Yes. Monica Arya is online. Who is present this study?
Yeah, actually, on place of Monica Arya, the Akhilesh Gaidhane will present the paper. So, Akhilesh, sir, please share your slide.
Okay. Dear
Akhilesh, sir.
Akhilesh is there. We can't hear you,
are not
sir.
audible actually.
Can you present?
Yes, he is presenting, just checking his connection.
Okay.
Just a minute. Dr. Akhilesh, you are not audible. Please share your presentation in a
share
screen.
your screen, please. Presentation screen.
In the meantime, can I ask Pooja Rani is there?
Yes, sir.
Pooja Rani, can you please present your paper? In the meantime, Dr. Akhilesh, kindly please rest assured that after the presentation of Pooja Rani, you please present the paper.
Yes.
Thank you.
Is my screen visible?
Yeah. It's visible.
Please, you have 10 minutes, please.
Yes. Good afternoon, everyone. Today I'm going to present my paper, Heart Disease Prediction using Bayesian Optimization Classification Algorithms. So, heart disease refers to a range of conditions that affect both the heart and its blood vessels. And heart disease encompasses several diseases like heart failure, coronary artery disease, and arrhythmia. Basically, coronary artery disease occurs when cholesterol and other substances accumulate in the coronary arteries, and these accumulated substances form the plaque. When the plaque build up, the arteries become narrowed, and due to the narrowed arteries, blood flow to the heart is restricted. And if this restricted blood flow forms a blood clot, then blood flow can be completely blocked, and which can result in heart attack also. And arrhythmia are the abnormal heart rhythms that can occur when there are problems with the electrical signals that regulate the heartbeat. We can use basically machine learning for heart disease diagnosis, and the area where we can use is the risk prediction by considering the various variables like age, gender, medical history, lifestyle factors, laboratory results. Machine learning models can be used to predict heart disease, and machine learning algorithms can also be used to perform analysis of cardiac MRI to diagnose heart disease. It can be used to perform the analysis of ECG for the detection of arrhythmia and other cardiac abnormalities. And they can be used to integrate patient data, medical records, and personalized treatment plans can be provided to the patients. Research contributions of this paper is basically a methodology is proposed in this paper for heart disease prediction using the Bayesian optimization classification algorithms. So important features for the prediction of heart disease are selected using the genetic algorithm. And after selecting the features, performance of 4 classification algorithms, random forest, spot vector machine, adaptive boosting, and extreme gradient boosting is evaluated. And after that, hyperparameters of the machine learning algorithms are optimized using the Bayesian optimization algorithms. And finally, a methodology is proposed for the heart disease prediction. Then literature survey is done of existing literature. Pasha et al. Evaluated the performance of DT, SVM, KNN, and artificial neural network, and where KNN achieved 67.2% accuracy, SVM DT achieved 81.97% accuracy, and ANN provided the maximum accuracy of 85.24%. And Jindal et al. Also evaluated the performance of 3 classifiers, in which maximum accuracy was achieved by using the LR of 87.5%. Rubni et al. Compared the performance of 4 classification algorithms, and random forest performed the best with the accuracy of 84.81%. Al-Qadani proposed an ensemble method. Ensemble method was developed using random forest, KNN, DT, and XGP, and ensemble model provided the accuracy of 88.70%. Chang et al. Provided the accuracy of 83% with random forest. Batane and Manak proposed MLP PSO algorithm, hybrid algorithm using the multi-layer perceptron particle swarm optimization, which provided the 84.61% accuracy. Rahman et al. Provided the max accuracy of 81.10% using the machine learning algorithm XGB, and 85.41% using the deep learning method. Bhatt et al. Used K-modes clustering method to increase the classification accuracy of several models, and MLP achieved the highest accuracy of 87.20%. And Osgar and Pecker used the CART method, classification regression tree method, to predict the heart disease and achieved the 87% accuracy. For performing the various experiments, UCI data available on UCI was used, in which there was total 13 features, and finally it was predicted that disease person can be suffered from the heart disease or not. And this is the proposed methodology. Firstly, the heart disease data set is taken, then pre-processing is done by dropping the missing data. Records having the missing values are removed, and after that, feature selection is done using the genetic algorithm. Relevant features are identified, and then standard scalar is used to normalize the data so that all features have the same range, and class balancing is done using the SMOTE. Class balancing was required because 2 classes was imbalanced, and 1 class was having the more number of reports as compared to the other class. And after the pre-processing, classification was done using 4 classification algorithms: random forest, spot vector machine, AdaBoost, and XGBoost. And after that, optimization of these classification algorithms was done using the Bayesian optimization, and performance were evaluated using the K-fold cross validation method, and heart disease was predicted. This table shows the performance of classifiers without the optimization. And we can see that random forest has achieved the maximum performance in all the performance parameters, and it has achieved the maximum performance like accuracy, precision, recall, specificity, and F1 score. Performance of random forest was best. And then all these hyperparameters of all these classifiers were optimized using the Bayesian optimization. And this table shows the hyperparameters that were optimized and their optimized values also. And after that optimization of hyperparameters, performance of optimized classifiers were evaluated, and here random forest has provided the maximum performance and provided in terms of all the parameters that is achieved the maximum accuracy of 86.87%. This diagram shows the comparison of the classifiers accuracy before optimization and after optimization. As we can see in this diagram, that after optimization, accuracy for all the classifiers improved. And similarly, recall of all the classifiers was improved. And this it shows the specificity, then precision, then F1 score. And this diagram shows the accuracy comparison of all the classifiers after optimization. And random forest has provided the maximum accuracy. So random forest is basically a proposed methodology. And this is the comparison of ROC curve of all the classifiers. And here also random forest has given the maximum value for AU ROC, area under receiver operating characteristic curve. And proposed system, that is GA-RF. GA was the feature selection that was done using GA, and random forest was our optimized classifier. Proposed methodologies compared to existing methodologies also. Work is compared to latest research work, and our proposed system has given the best values. Finally, it is concluded that GRFE methodology is proposed as a means for predicting heart disease using Bayesian optimization. Authors investigated the effectiveness of classification algorithms like SVM, RF, AdaBoost, and XGB. And their hyperparameters were optimized using Bayesian optimization. And the results integrate that optimization enhanced the performance of all the classification algorithms, because before optimization performance was low, and after optimization performance of all the algorithms increased, and random forest has given the maximum accuracy of 86.87%. These are the references used for the paper. Thank you.
Thank you for your presentation. Dear participants, do you have any question about the study?
Yes, Professor, I'm having a question.
Okay.
Pooja, can you please come to the result section?
Yes, sir.
While optimizing the classification of the algorithms,
yes, sir.
What is the best result you have received from where?
Sir, random forest.
Okay.
Just a
And
minute,
other
sir.
than random forest, what are the other classification methods you have used?
So classification methods were used for the SVM, AdaBoost, and XGBoost.
Okay, while optimizing, what are the functions actually you have used?
Bayesian optimization.
No, I am asking about the functions. This is the method, Bayesian.
Yes, sir.
Okay, no issues. Very good presentation indeed. Thank you, Pooja Rani.
Thank you, sir.
Now, I think we can close that Monica Arya presentation, please. Monica Arya, are you there?
Sir, am I audible now?
Yes. Akhilesh ji, you are audible now. You may present, please.
Thank you very
Adaptive
much, sir.
streaming feature selection technique for classifying non-stationary data streams.
Dear Monica Arya, can you hear me?
I
Hello.
think on behalf of Monica,
Are you
Akhilesh
able
will
to
present.
Yes. On behalf of Monica, I will be presenting, sir.
Please share your screen, sir.
If you are ready, you can start your presentation, dear Monica Arya.
Dear Akhilesh sir, please share your screen. We are late in the timing. We are getting late.
Dear Monica Arya, do you want to make your presentation?
Just give me 1 minute, sir. 1 minute. Just give me 1 minute. Dr. Bhupesh, can you please connect with Akhilesh?
Yes, sir.
It will be taking time.
Yes, sir.
Okay, you can share your screen, dear Monica
Sir,
Arya.
just 1 minute. There might be some issue. Just give me 1 minute. Only 1 minute.
Okay. Dear participants, after the session,
just 1 minute, sir. 1 minute. I am on call. 1 minute, just.
Okay, no, no problem. After the session, at 10:30, if you are available, I want to attend the special session.
Sir, actually, there is some network issue. I am just presenting on behalf of Monica Arya. Give me 2 minutes.
Okay.
Hello. Am I
Hello.
audible, sir? Now I am audible, I think, and screen is also getting shared.
Yes, sir. You're audible.
Thank you very much, sir. And
Yes,
can you
please
see
go
my
ahead.
screen also?
Yes.
Yes, sir.
You
Sir,
you
just
have
for your
10 minutes,
information, this is the paper ID and adaptive streaming feature selection technique.
Yes,
for
selection techniques
classifying
for classifying non-stationary data streams. Yes, sir.
Yeah, please go ahead. Thank you.
You have
Uh,
10 minutes, please.
Yes, sir. And sorry for the delay. Myself, Akhilesh Gardner. I'm presenting this paper and adaptive streaming features selection technique for classifying non-stationary data streams. The authors are Dr. Monica Arya, Dr. Bhupesh Dewangan, Dr. Tanupriya Chaudhary, Ketan Kotecha, Dr. Sanjana Dewangan, and Dr. Akhilesh Gardner. So contents of this paper is these are the introduction. Then we will go to problem statement, motivation, contribution from where we have got and what we have contributed, related work, how we have done that methodology, result and discussion. First of all, I will go for the introduction, and we have done there's two types of data are there actually. They are of the static and dynamic. Both have the different features. And nowadays we are dealing with the dynamic data whose characteristics are fast, rapid, ever-changing nature, new challenges to handle. Data streams are rapidly increasing owing to the proliferation of various modern applications. These special characteristics of data streams pose new challenges to the researchers. Efficient processing of real-time data streams enables various intelligent and automatic actions. Therefore, there is a growing need for adaptable classification algorithms because conventional algorithms are not adaptable to the changing concept in the data streams. Now about the problem statement, an extensive dimension of the data streams and the drifting of a relevant subset of features over time can significantly degrade its performance. As a result, researchers face a significant challenge in developing an effective algorithm for categorizing data streams. The relevant feature selection can build an efficient classifier. Next is the motivation and contribution. The current work was motivated by consideration of the relevance and redundancy of features. The following is a list of distinctive contributions that set apart this work from other approaches. The process of feature selection involves determining the significance of a feature in relation to the target class. Feature relevance-based adaptive feature selection is presented to control the feature selection in real-time streaming, and the performance of classifiers using adaptive streaming feature selection algorithm is compared with classifiers using traditional feature selection techniques. About the related work, the study of related and relevant literature has revealed the following facts: that to improve the classifier's performance, feature selection is applied to data sets to remove redundant and irrelevant characteristics. It establishes which features are most crucial and takes advantage of them. Feature selection helps in timely and accurate feature selection, which can reduce computational and storage costs, improve computational time, increase generalization, and prepare clean, understandable data. This process improves overall performance. Feature level changes occur when new features appear in the data streams. Few studies have been conducted in this area. This problem is very challenging because dynamic feature spaces can include emerging new features or discarding some features. Efficient models for classifying streaming data should be able to learn from newly arriving features and must be adaptable to the possible changes in the data distribution. Researchers have continuously developed new techniques to improve classifier performance in non-static data streaming mining using feature selection methods. The pertinent characteristics are retained while eliminating those that are not relevant. And this is the methodology in this proposed adaptive feature selection algorithm. The training dataset X, class labels Y, and testing data for X are fed as input. The variables, that is current error rate, previous error rate, and threshold initially set to 0. We can see data streaming, then we data processing, applying classification. Here we are variables, that is current error rate, previously, and threshold are initially set to 0. In this, the variable CER, and for the next step, CER, that is current error rate, is calculated from the following formula. Now, a threshold is calculated based on the current error rate and the previous error rate using the following formula. The value of the threshold indicates the increase or decrease in the current error rate concerning the previous error rate. If the value of threshold is positive, it indicates a higher current rate, while negative or zero value indicates the stability of the model. In this way, the feature selection technique is adaptive to incoming concept change and thus reduces the computational overhead. Next is these are the full forms that adaptive feature selections algorithms. What we have used in the previous slide for the formulas. These are the steps how we classify, calculation, calculate threshold, and if threshold is greater than 0, apply algorithm 2. These are all the steps of the flowcharts. how the input and output all the of the same flowchart. Now, lastly, we come to the result and discussion. The performance of the classifier is summarized in 3 scenarios without using feature selection technique, by using traditional feature selection technique, by using adaptive streaming feature selection technique. The tables below show the performance of state-of-the-art classifier over synthetic and real-time datasets in all the 3 scenarios. The accuracy, precision, recall, F1 score, and the computation of the time of all the classifiers with the individual dataset is determined, and average accuracy of each classifier is calculated. These were the results without feature selection techniques. Here we have compared without using feature selection and with using feature selection, how we have got the accurate and good results. The overall comparison shows the improvement in the performance in when the feature selection technique was used and the performance was further enhanced. The adaptive streaming feature selection technique was used. In this way, we have got a good and better result and accurate result. Conclusion and future scopes. Streaming data generated through multiple activities such as customer transaction, social media, tweets, websites, etc. are boundless and will grow faster in the coming years. Streaming data requires immediate and efficient processing to extract knowledge from it. The proposed method utilizes the adaptive streaming feature selection technique for the classifying data streams efficiently. The 7 data sets were experimented with the benchmark algorithms for data stream classification, and the results were compared with 5 parameters. The classification accuracy is increased or remains the same, but the computational time is reduced significantly by applying the proposed technique. This shows that the technique presented in this paper improves the accuracy and reduces the computation time for prediction, hence improving the classifier's overall performance and avoiding model overdrifting. The proposed work opens several spheres and researchers working in this area, such as combining the approach with automated system for real-time prediction and analysis, and also with the nature-inspired algorithms. These were the references from the different scopus and different papers we have taken. If any queries, it is most welcome.
Okay, thank you for your presentation. Dear participants, do you have any question about the last study?
Yes, I have a question about this feature selection. Could you go to the slide where you explained this? How did you achieve this feature selection?
Dr. Akhilesh, she is asking how did you achieve the feature selection over here?
Yes. This booster method, because you said if you put this method before the classical algorithms, it is boosting the solution. And
yes,
now
this is the methodology what we have used this feature selection about. Yes, the main feature selection. Yes.
These the first slides. You showed this method. How do you do it?
Yes, I have already showed this method. And in this, only one thing is there, that the threshold, the variable current rate and that threshold is already set to 0. And if we have got above the threshold is above 0, prediction if no, then we again go to the apply classification algorithms, and we again and again apply that classification algorithms, and we use this till we got the threshold that is equal to 0. Then only we will got the result for this.
I understood you. Iteratively, it's missing, iteratively,
Yes,
omit.
and for accuracy, we have to go again and again if not got that threshold value, and we have to apply this loop again.
Okay. Thank you very much.
Thank you, ma'am.
Thank you. Nice question and nice acknowledgement. Answer. Thank you.
Okay.
Thank you, sir.
Okay, thank you for your presentation. I wish you success, dear Akhilesh Gaithane.
Thank you, sir.
Thank you. I think all the presentation for this session has been done. No?
Yes.
Yeah. Thank you. Thank you very much.
Thank you for your
Can we
attending.
all switch on your camera and take a snap of it?
Yes. Dear participant, I want you to attend the special session at 10:30 if you are available.
Dr. Akhilesh, kindly stop sharing, please.
Sorry?
Dr. Akhilesh, kindly stop sharing as because your last
Okay.
slide is still visible.
I have already shut down the computer screen, but I don't know how it is showing.
Otherwise, we will not take the photographs. No?
Yes, sir.
Okay.
Yeah, now it's fine.
Thank you very much for your attending, dear participant. The session is over. First session is over. I would like to end this session. Have a good day. Good luck.
Same to you all of you. Thank you.